Hi students, this is Ramya from Pharma Tools and today we are going to explain Claisen condensation. It is a condensation reaction between two enolizable esters. Enolizable esters means which contains alpha hydrogen in presence of alkoxide base in alcohol to form beta keto ester. So let's see the example. So here 2 moles of ethyl acetate which is enolizable ester which contains alpha hydrogen. In presence of alkoxide base, it will give beta keto ester. So ethyl acetate will give, this is alpha carbon and this is beta carbon. At beta position you have keto group. So this is beta keto ester. Ethyl acetate will give ethyl acetoacetate which is a beta keto ester. So in Claisen condensation, we should use alkoxide base. We should not use hydroxide base. We should use alkoxide base only. If you use a hydroxide base, then it may lead to ester hydrolysis. And alkoxide ion base, we should use, suppose here alkoxy group in the ester is ethoxy. Then we should use sodium ethoxide in ethanol. So alkoxide ion should correspond to the alkoxy group in the ester. Suppose here alkoxy group is methoxy means we should use sodium methoxide in methanol. So otherwise it may lead to trans-esterification. So alkoxide ion should correspond to the alkoxy group in the ester. So here ethoxy group is there. So we are using sodium ethoxide in ethanol solvent to form beta keto ester, that is ethyl acetoacetate. So now let's see the mechanism involved in the Claisen condensation. So as it is similar to the Aldol condensation, the difference is it is a reversible reaction, and here esters undergo condensation in presence of alkoxide base. So now let's see, the first step involved is the formation of a nucleophile or a carbanion. So in presence of sodium ethoxide, say ethoxide anion will, what it will do, anion base, it will abstract the hydrogen. Which hydrogen? Alpha hydrogen. So alpha hydrogens are abstracted by ethoxide ion and it will give rise to nucleophile, that is carbanion, that is CH2 minus C double bond O C2H5. So this carbanion is also called as ester enolate. So ester enolate ion is formed from the ester molecule when alpha hydrogen goes off by the base. So this is the first step involved in the Claisen condensation. So the carbanion, or it is also nucleophile, it will attack the second molecule of ethyl acetate. Here we are using 2 moles of ethyl acetate. So it will attack the second ester molecule. So where it will attack? Always carbonyl carbon provides 2 sides. So always nucleophile will attack electron deficient carbon atom. So it will lead to formation of a alkoxide derivative. See this CH3, oxygen is taking the electrons, and let's write this alkoxy group here, that is ethoxide group, then attach this anion to the electron deficient carbon. So this is the alkoxide derivative obtained in the second step when nucleophile attacks the electron deficient carbonyl compound. As I told, these are reversible reactions. And now what happens in the next step? See, this is a reversible reaction, see this electrons will come here and this ethoxide ion will go. So now we got keto group there. See this CH3, C double bond O, and this ethoxide is leaving CH2, C double bond O, C2H5 plus ethoxide ion. So this is obtained from the third step when ethoxide ion leaves. So but you see here, see the structure of this. This is beta keto ester. So we cannot conclude, logically it is correct that we got the product from the Claisen condensation, but it is not, because these hydrogens are very acidic. The beta keto ester is a strong acid compared to the normal ester because of the presence of two acidic hydrogens here. And this is reversible reaction, and we may not achieve a good yield of a beta keto ester. So the reaction will continue. See here, it's all reversible reactions, and since it is very strong acid in presence of ethoxide ion, what it will do? It will abstract the hydrogen from the alpha carbon. This is alpha carbon. So you'll get CH3, C double bond O, CH, C double bond O, O, C2H5. So you'll get a anion which is very N plus alcohol, C2H5OH. So you got ethanol, and this is very stable anion. The anion is very stable and it will form a sodium salt. It will form a sodium salt. It is very stable because of the presence of two carbonyl group in this. So let's write this hybrid structure. See, since it is having, anion is having two carbonyl groups, so it is highly stabilized ion because of the resonance. Because of the resonance, it is highly stabilized anion which will form a sodium salt. So this is sodium salt of acetic ester. So formation of a sodium salt of acetic acid ester is a key for the success of this reaction, because see, this step is forward reaction. So it favors only forward reaction so that we can achieve a good yield of a product. So once this sodium salt forms, after workup, after acidic workup, protonation occurs. So after workup, protonation occurs. So where the proton is added, so proton will attack the anion. Proton will attack the anion, and finally we will get beta keto ester with good yield. See, this is the product, final product obtained from the Claisen condensation, that is beta keto ester or ethyl acetoacetate. Ethyl acetoacetate. So this is the mechanism involved in the Claisen condensation. See, in the first step, nucleophile is formed, and in the second step, nucleophile attacks the electron deficient carbon to form alkoxide ion. This is alkoxide derivative. So which then ethoxide ion will go to form beta keto ester, but it will not get a good yield because it is a reversible reaction. And the product obtained is beta keto ester, which is highly acidic because of the presence of two acidic hydrogens. So it will very strong acid, and in the presence of ethoxide ion it will give a stable anion, and it is getting stabilized due to resonance, and it will form a sodium salt of acetoacetic ester. And this on protonation or acid workup will give beta keto ester. So this is the mechanism involved in the Claisen condensation. So if you understand, please like, share and subscribe my channel for more videos.